Okay, let's solve this quadratic inequality. What we're going to do first is to transpose this to the left hand side so that our right hand side will be 0. That is x squared, and this is now this positive. If we transfer it or transpose, that will become negative 10x, then plus 21, that's greater or equal to 0. Express this into factors. Okay, you can use the FOIL method. Okay, the f of our FOIL method is x, and x here, so that x times x gives us x squared, and then the third term, we get the factor of 21. 7 and 3 can work out to give us the middle term of negative 10x. Okay, so we use the negative and negative, because negative 3 times negative 7 gives us positive 21, so our L of the FOIL is good. And then let's look at the middle term, and it gives us negative 3x, negative 3 times x, negative 3x, and this one negative 7x, and if we add that, it gives us negative 10x, which is the middle. Okay, now what we're going to do next is to get the critical points. So to get the critical points, or the zeros of our inequality, is to equate our inequality, change the inequality into 0. So this is now x minus 3 and x minus 7 is equal to 0. So that means our x is equal to 3 to make this 0. 3 minus 3 is 0, and then x equals 7 to make this 0. 7 minus 7 is 0. Okay, now this inequality here is important, okay, because we will be using this in our in finding the solution. Okay, next is, let's construct the real number line, okay, with our critical points in it. So we have 3 and 7. So from real number line, we form 3 intervals. This interval here, 1, 2, 3. Okay, so what we're going to do next is to get test points from these 3 intervals. So from here, so this is from negative infinity to positive infinity. So this interval here, 0 belongs to it. Okay, we can use 0. You can use any number in here. It could be 1, 2, 0, negative number. Okay, 0 is easier for me. Okay, this one you can use 4, 5, 6. Okay, any number between 3 to 7. I'll take 5. And this one here, let's take 10. Okay, these are our test points. Now let's use our test points to this inequality here. So when your x is 0, let's go back here. If it's 0, so we have negative. Our first factor is negative. And if x is 0 here, that's negative 7. So second factor is negative. So if you multiply negative times negative, that gives us positive. So this interval here works. This interval is true. Okay, let's go to this interval, the second interval. Okay, so if our x is 5, so 5 minus 3, that gives us positive. That's positive 2. And x equals 5, so 5 minus 7, that's negative. And positive times negative, that it gives us negative. So this interval here does not satisfy the inequality. And then let's go to the third test point. So x equals 10. So 10 minus 3, it gives us positive 7. Okay, it's positive. And 10 minus 7 here, that gives us positive 3. So that's positive. And then positive times positive gives us positive. So this interval here works, and it's true. So we have 2 intervals that satisfy this inequality. And if we draw the interval, since 7 is included, so that's 7 up to positive infinity. And this interval here, 3 is included because the zeros here is included, so it goes to negative infinity. So if you write the solution set is equal to the interval from negative infinity to 3, and 3 is included, so we use the closed interval to the right. And then this interval here, we just union it. Okay, 7 is included, then goes to positive infinity. So this is now the solution set. If you want to write your solution in interval, then it's also correct. You can write it like this: the set of x such that your x here is less than 3, right? So x is less than equal to 3. X here is a real number. Then since this is union, and union is OR in sets, then our x here is greater than 7, greater than or equal to 7. So x is greater than or equal to 7. So you can write your solution in interval notation or in set notation. Okay, next we have this rational inequality. So what we're going to do is we have to express this into full factors. So notice the numerator can still be factored out, and there's the common factor is x, so we can factor that x, and this gonna be x here and 5, because when you return that out, x times x gives us x squared, and x times 5 gives us 5x, and then copy the denominator. It's greater or equal to 0. So this is our important, this is the important part of our inequality now, because we'll be using this in our test points. Alright, now to get the critical points, you can change this into equality, or if you're lazy, you can just get the critical points right away. X equals 0, because x is 0, everything here will be 0. So x equals 0, and then here x equals negative 5, that gives this, that makes this 0 at x negative 5, and then at x equals 3. Okay, next is let's draw the real number line from negative infinity to positive infinity with our critical points negative 5, and then 0 and 3. So we have 4 intervals, 1, 2, 3, 4. Okay, so our interval here, negative 5 is at the numerator, the zeros, negative 5 is at the denominator, so that is included because our inequality is greater than or equal. The zeros are included at the numerator. Okay, and our 0 here, x equals 0, that's also included because it's at the numerator, but x equals 3 is not included because it's at the denominator, because if x is 3, our denominator will become 0 and the whole thing will be undefined. So there it is. So we have this interval going there, interval between negative 5 and 0, then 0 to 3, and then 3 to positive infinity. So these are the 4 intervals. Okay, let's now do the test points. Let's pick a test point here. Negative 6, negative 7, negative 8. Could pick any. I'll pick negative 6. Here we have negative 1. I'll pick negative 1, easy. And this one I'll pick 1, easy. And here I pick 4. Okay, now if this x is negative 6, so this one will become negative. That's negative 6, right? The first factor. And then the second factor, that's negative 6 plus 5, that's negative 1, so it gives us negative. And the denominator, negative 6 minus 3 is negative 9, so it's gonna be negative. So negative times negative is positive, divided by negative gives us negative. Okay, That's negative, but this one is positive, so it gives us false in this interval. Okay, going to this interval, if -1, so the first factor will be negative. -1 plus 5, so that's going to be positive. -1 and -3, so that's -4, so denominator will be negative. So negative times positive is negative, and negative divided by negative is positive. So that means this interval here is true. Okay, let's go here. When x is 1, is going to be positive there, the first factor. And 1 plus 5 going to be positive 6, so the second factor is positive. At the denominator, this is positive 1 minus 3, that's negative. And this gives us positive times positive is positive, divided by negative is negative. So this interval here is false. Let's go to the last interval. If x is 4, that's positive. First factor is positive. 4 plus 5 is positive. 4 minus 3 is positive. So positive times positive, positive, divided by the positive is positive. So this interval here is true. Solution set. Okay, the solution set is the interval from -5. -5 is included because at the numerator, and then up to 0. 0 is included because it's at the numerator, and then union of from 3. 3 is at the denominator, so it's not included. That's open interval, open from left, going to the positive infinity. Okay, there you go. If you want to write this to set notation, so that is x such that our x is between -5 and 0, or because that's union, or x is, our x here, okay, is greater than 3, that's open, and then up to positive infinity. Okay, positive infinity is always open, or negative infinity always open, because it's not a number. Okay, so this is now the solution set.